Good afternoon, everyone. In today's session, we will be discussing about next important concept of data mining and also machine learning, that is support vector machine, which is a widely used classification method in any area, right? So, support vector machine, we call it as SVM in general, is one of the most popular supervised learning algorithm. So, as I said in previous session, decision tree is an example for supervised learning. In the same manner, support vector machine also comes under supervised learning algorithm. So SVM can be used as classification method or technique, or also as regression method. That means it is used for classifying many objects. For, if I say I want to classify boys and girls in a classroom, then I can use this classification method called as SVM. The same manner, if I want to say do some predictions, then I will be using SVM for regression also. Okay, but the major use of SVM comes under your classification problems only, because we actually use a logistic regression, linear regression for regression based elements. SVM is mostly used for classification problems. Okay, yeah. So when you're talking about your SVM, the important concept to be discussed in SVM is hyperlane, which is the separation of classes in your data. Okay, so the goal of SVM algorithm is to create the best line or a decision boundary that can segregate n-dimensional space into classes, so that we can easily put the new data point in the correct category in the future. Which means, as I said, the example, suppose if I am having some data points of boys and girls, then if I want to separate boys and girls separately, I need to construct an hyperlane. That is, a separation metric should be available. So that is the main goal of this SVM. So if it want to classify a new object depending on the features, so it need to have a classification technique. That's what it's called as a hyperline. The best decision boundary is called as a hyperline. So I'll be showing pictorially about what is this hyperline here. So here you can see a graph indicating about various parameters of SVM. So the line which is drawn here, the thick line here, indicates your hyperplane. Okay, the hyperplane is the separation of two classes. So here you can see you're having two classes, one is blue squares and circles, one is green. So if I want to separate them equally, then I need to use a hyperplane, which is called as important separation or segregation line between 2 points. Okay, so SVM chooses the extreme points or vectors that help in creating the hyperplane. The main goal of this SVM is to choose a hyperplane. That is, a separation boundary should be drawn. It can be linear line and it can be any line which need to be drawn. That is the main goal of this SVM. Once a hyperplane is constructed or drawn, then it is easy for SVM to classify things accordingly. The extreme classes or cases are called as support vectors, which you can see here. Here you can see the green color and blue color indications are the support vectors. So we are going to separate those two vectors. That's why it is called as support vector machine concept. Okay, so hence the algorithm is termed as support vector machine. Okay, everybody need to note this important point. What is an hyperplane? So hyperplane is a separation line between two classes or two feature vectors. The supporting vectors or the support vectors are the ones which are indicated in blue and green colors, which are called as the classes in your given data set. Okay, so in this SVM algorithm, we plot each data item as a point in n dimensional space. Okay, so we will be having data points in different dimensions, and we need to plot this into a dimensional space with the value of each feature being the value of particular coordinate. So here you can see a x-axis and y-axis, x1 x2 are the points here which need to be taken into consideration. Then we perform classification by finding the hyperplane that differentiate the two classes very well. So in today's session, the main discussion about SVM is how to construct an SVM, how to construct an separation line, or what we call as a hyperplane, in different scenarios. So here you can see the classes are very easily separated, and it's very easy for us to understand about what is a hyperplane. But what if the points are mixed up? Assume that some blue points and some green points are mixed up, then we need to separate those points. That is the actual concept of these support vector machines. Okay, so SVM algorithm can be used in a number of applications, like it can be used in face recognition application, it can be used for intuition system, it can be used for text categorization, it can be used for image processing. So SVM has wide applications in many areas where you are having data in different classes. Okay, yeah. So talking about the concepts of SVM, SVM is classified into two types, that is linear SVM and also non-linear SVM. So linear SVM is very simple. If you are able to separate the data points with a single linear line, then it is called as linear SVM. So linear SVM is used for linearly separable data. If the data whatever you are having, suppose here you can see that we can easily separate two data points linearly. This is an example for your linear SVM. If you are unable to separate those data with a linear line, then it is called as non-linear SVM. Okay, so talking about this linear SVM, if a dataset can be classified into two classes by using a single straight line, then such data is termed as linearly separable data. And a classifier used at this point is called as linear SVM classifier. So whenever you're talking about your SVM, so if you are having the data points which can be separated easily using a linear line or linear separation, then we use linear SVM algorithm. Suppose if you are unable to do that using linear line, then it is termed as non-linear SVM. So non-linear SVM is used for non-linearly separated data, which means if a data set cannot be classified by using a straight line, then such data is termed as non-linear data, and classifier used is called as non-linear SVM classifier. Okay, so everybody need to understand these two important classification, why it is termed as linear SVM, because it can be separated by a linear line. If it cannot be separated by a linear line, it is non-linear SVM. Okay, yeah. So here comes the scenarios about how to select a right hyperplane. So now we are talking about how SVM works and what is the working methodology of these support vector machines. So the main question arises here is, how can we identify the right hyperplane? So here you can see in between x and y axis, you are having some data points indicated with circles in red color and stars in blue color. Now here I am having three. As I said in the previous concept, if you are able to separate your data with linear line, it is called as linear SVM. But here I can draw linear line in any manner. Here you can see A is one linear line, B is one linear line, and C is other line. But among this linearly separable, we need to select a hyperplane which can classify both of them equally. So among them you can see which one is the best one, you need to identify. So for this can anybody say which is the best line among this A, B, C? Yeah, so we need to understand here which among these data points, which among these A, B, C is the best hyperplane. Yeah. So now in this scenario here we assume that we are having A, B, C. Now we need to identify the right hyperplane to classify star and circle. So now if you want to select the proper hyperplane, you are having a thumb rule to be remembered. That is, select the hyperplane which segregates the two classes better. Which means here hyperplane B is selected as the better hyperplane among A, B, C, because hyperplane or the linear line B is separating both the classes equally. If I consider A is only segregating stars separately. It is not concerned about circles. Half circles are, you can see 5 points are above the hyperplane, 3 points of circles are below the hyperplane. In the same manner, if I talk about C is also not separating the lines between stars and circles properly. Only B is doing this task perfectly. That's why B is considered as the better hyperplane among the three planes. Okay. Now, in this scenario, can I get some answers? Which among these is considered as the better hyperplane? Yeah, let's see what's the answer here. So here we are having three hyperplanes A, B, and C, and all are segregating the classes well according to the previous rule. Now, how can we identify the right hyperplane? Okay, so here we need to understand one important concept: maximizing the distances between nearest data point, either classes, and hyperplane will help us to decide the right hyperplane. This is called as margin, which means so I need to identify among these three, which is classifying data points exactly. So here you can see, if I consider B is doing favor for stars, and A is doing favor for circles. So I'll just go to the initial discussion of the concept. Yeah, so here you can see, as I said in the about that SVM, here you are having three classification, that is similarly A, B, and C. But here the between the thick line is considered as the hyperplane because it is having maximum margin among these two. Okay, that's the reason I am considering C as the better hyperplane here. Okay. Now let's go for the next scenario to select a proper hyperplane. So now here you can see the understanding of what we have seen in scenario 2. So if I say A is a hyperplane, but he is not able to classify stars appropriately. That's why we are selecting C, because it is having the maximum margin between these two circles. Okay, yeah, that is the explanation for the previous concept. Okay, so here you can see that the margin for hyperplane C is high as compared to both A and B, hence we name the right hyperplane as C. Okay, so while answering in examinations, you need to explain these scenarios with the same reasons. Okay, you need to draw these graphs clearly, how you're separating hyperplanes, and explain them with a proper reasoning. So another lightning reason for selecting the hyperplane with higher margin is robustness. So if you're selecting C as the better hyperplane, your algorithm will be robust. If you are having selecting A and B as your hyperplanes, it may lead to some misclassification. If the next data point is nearer to the next B, then it may lead to some misclassification. That's the reason we are selecting C as the better hyperplane. Okay. So now we are having one more scenario here. The next scenario. Now you need to identify the better hyperplane among this A and B. So give your answers, guys. So the solution for this one is answer is A. Let's know the reason why A is selected as the better hyperplane among these two. Okay, some of you maybe have selected B as a hyperplane as it has the highest margin compared to A. But here we need to meet the constraint that both of them should a hyperplane need to classify both the elements properly. But if I am selecting B as the hyperplane, it is having a maximum margin, but it is eliminating one of the data point. That's why here B is not considered as the right hyperplane. Okay, so here SVM selects the hyperplane which classifies the classes accurately prior to maximizing margin. So before selecting this maximizing margin concept, you need to select that it should separate both the classes equally. So if I select A, then it is meeting that criteria. So here hyperplane B has a classification error and A has classified all correctly. Therefore, the right hyperplane is A. Okay. So I hope everybody is understanding how this concept is being established, right? So now we are having the next scenario, how to classify these two classes. Okay. Think and give me answers for this one now. Now let's see how to solve this problem now. How should I separate this classification between the stars and circles using a hyperplane? Okay. Yeah, there was a small disturbance and internet due to internet issues. I'll just share my screen. Okay, so here I am unable to segregate the two classes using a straight line, as one of the star lies in the territory of the other, that is in the circles. So now this point which is in the other territory of circles, it is called as outlier. So outlier is one important concept of data mining and machine learning. So outlier is a point which is deviating from the actual path. So here all the stars are towards a separate layer, and only one of the point is causing disturbances, and this point should be eliminated. Then only I can construct a hyperplane. Otherwise, you will be having a classification error, and that may not give you a proper classification. That's the reason whichever the point it is causing a problem, that point need to be eliminated. But what if I am having many points here? Here, because I'm having only one point, I can remove this point, and that may not cause me problem. Okay, so to make a proper decision, one if I remove one point, that may not affect the actual classification, so I can remove one point. Okay, so as already mentioned, one star at the other end is like an outlier for star class. So svm has a feature to ignore outliers. So whenever you are having such type of difficulties in selecting a hyperplane due to one or two points, that point is considered as outlier, and SVM will understand that this point is deviating from the actual path. That's why it is considered as outlier, and that can be eliminated. So outliers need to be eliminated whenever they are causing some disturbance. Okay, so finding the hyperplane that has the maximum margin, hence we can say SVM is robust to outliers. So this is one of the important advantage of choosing SVM as the better classification. So SVM automatically tunes up the outliers, and it will eliminate the outliers. And then if I remove that point, it is very easy for me to construct a hyperplane. Okay. So now this is the scenario number 5. Now find the hyperplane which segregate the equal classes. So is it possible for me to select a proper hyperplane now? Yes. Okay. So now this is a scenario where it is very difficult for us to uh, construct a hyperplane that is a linear hyperplane. That's the reason we are having two types of SVMs. That is linear SVM. Other one is non-linear SVM. So as Nawaz correctly pointed, we cannot construct a linear line here, sir. We can construct a circle. Okay. Let's see now what is the solution for this one. So in this scenario, we cannot have a linear hyperplane between the two classes. So how does SVM classify these two classes? So till now, we have only looked at the linear hyperplane. Now let's talk about the next concept, that is non-linear hyperplane. So now this data, the same graph, whatever you are seeing here, the stars and circles here, that can be converted into this form. This can be done using SVM. So whenever you are having such type of problem, then I can go for this type of classification. So what do you mean by this, sir? Okay, that is your question, right? So SVM can solve this problem easily. It solves this problem by introducing additional feature. That is, we are going to square that formula. So here you can see some points are below the negative margin, right? Some are positive, some are negative. If I apply squaring, then I can get this type of data. The same data, when I apply square, that is x square plus y square, even negative data will become positive, and all the data will be above your initial line. That's why your data you can see as the positive data. So in this graph, we can consider as some points like all the values of z would be positive because z is the squared sum of both x and y. So previously, when I took those data, z was negative. That's the reason some points are positive, some are negative. So in the original plot, red circles appear close to the origin of x and y axis, leading to lower value of z, and star relatively away from the origin, result to the higher value of z. That's the reason when I go for a squaring of these points, I'll get z value as positive. Then it is easy for me to construct a hyperplane between these 2 points. Okay, yeah. Now that is how we can go for your separation. And also, as Nawaz pointed out, we can use circle also. It comes under your non-linear SVM classification. But linear SVM classification is much easily understood than non-linear, because here in this graph you can see points are stars are above circles. But what if one of the star or two stars are in between these circles? If it is nearest to origin, suppose if they are having a mixture of elements, then the correct solution is you need to go for this squaring or any other way of identifying your data points. That will be easy for us to classify your data accordingly. Okay, that's all about your hyperplane classification. Now let's talk about one important point of this uh, SVM. As I said, hyperplane and margin are the important concepts of SVM. In the same manner, we talk about one more important concept of SVM, that is about your kernel trick. Okay, so coming to the major part of SVM for which it is most famous, that is your kernel trick. Okay, so this is one important question which is asked in many interviews, and also if you are good at research, if you are going for higher studies, this is one important concept which everybody need to understand. So what is a kernel in SVM? So kernel is a way of computing the dot product of two vectors x and y. So previously we have seen whenever you are having some negative points in your data points, we have applied some square, that is x square plus y square, x into x plus y into y. So that is some dot product of some elements, right? So a kernel function or a kernel trick in SVM does this task. Okay, so which is why kernel functions are sometimes called as generalized dot products. Okay, so now let's talk about what are the types of kernels. So depending on the type of data what you're having, SVM kernels are classified into three types. That is linear kernel, which is used for linear classification of data. Next, polynomial kernel, which is used for multiple classification of data. And next one is radial basis function, which is a very important uh, classification method, or which is a very important kernel type of SVM. So by default, kernel is radial basis function kernel. It's also called as Gaussian kernel. Okay, so talking about these basics of SVM, so we need to have a clear understanding of what is hyperplane, what is a margin, that is maximum margin line between two classes, and what is a kernel, types of SVM, and also types of kernel functions in SVM. So we are not going to talk in-depth concept of this because of syllabus restrictions. We are only concerned about the basics of this SVM. Okay, so concluding about pros and cons of SVM. So SVM is really effective in higher dimension. So whenever you are having higher samples of data which can be easily separated, then SVM is chosen. Best algorithm when classes are separable. So if you are able to separate classes easily according to given data points, then SVM is best chosen algorithm. But if data points are grouped into a combination of various aspects, then SVM is not preferred. The hyperplane is affected by only the support vectors, thus outliers have less impact. So because we can, by selecting the hyperplane, you can select the outliers, you can identify the outliers easily. So detecting outliers is very easy using your SVM. So SVM is suited for binary classification, that is yes or no or true or false, such type of data. If you are having only two classes, that is yes or no, or previously you can see green or blue, that's what we call as binary data, then SVM is most suitable. So cons, for larger data set, it requires a large amount of time to process because it need to do the squaring or dot products. So it may take a lot of time to select a hyperplane. So for larger data set, it's not muchly preferred. Does not perform well in case of overlapped classes. That's what we have seen previously. Whenever you are having overlap between two classes, it is not much preferred. Then we can go for any other classification method. You can go for decision tree, or you can go for naive based classification. So depending on the data what you are having, you will choose the better algorithm for classification. So selecting the appropriate kernel function can be tricky because sometimes you will be getting confused whether to go with radial basis function or whether to go with linear kernel function or polynomial kernel function. That depends on how you are going to select with your hyperplane. Okay, so that's it about your SVM, guys.